Hello, everyone. Good afternoon on this beautiful day. And we're here with the Cresco team doing a session on optimizing operations across industries. We're going to be focused on insights from healthcare, retail, and manufacturing as well. And on the Cresco team, it's me, Sanjeev Dada. Along with me, I've got Mason Chairman from Cresco, who's got a PhD in optimization and AI skills. So we'll go ahead and kick it off. Can we go to the next slide? So this session is going to be recorded and will be distributed as well. But just to go over what we plan on presenting in the next 60 minutes is talking more about the different industries that use optimization or are looking to use optimization. So industries like manufacturing, retail, and healthcare. And so we will discuss topics related to production planning, workforce scheduling, which is something that we see across many, many industries. We'll talk about supply chain optimization. We'll talk about resource allocation. And then finally, we'll talk about pricing optimization, which is a topic, once again, that is used across multiple industries as well. And so we'll also take a session on pizza making, and that's going to be for attendees. So we'll do a virtual pizza session with one of our partners. But before then, let me just jump into what our company does. So we have been in the business since 2012. We work with the hyperscalers and the products that they provide and they own. And so as a consulting company, we've been working with data science technologies and AI technologies, specifically decision optimization, to work on providing value as a consulting offering, right? So we work on return on investments, we work on profit margin improvements and new revenue opportunities. So when we look at a consulting opportunity, we look at it from cost cutting versus adding additional revenue. And so we focus on specific technologies around that. So with everything, data is central to what we do. So we have a really good offering from a data strategy and governance perspective. That's where we bring specialized tools, our skill sets, our offerings and framework and approaches in our consulting approach. And so with that comes consulting and advisory services. We help with software and infrastructure requirements to run those software solutions. Once the implementations are completed, we help with support services, and then obviously training and education is also a big part of our organization. So from looking at this circle over here, analytics reporting, financial planning, budgeting, forecasting, automation, data sciences such as machine learning and decision optimization are part of our offering. And then obviously anything that relates to cloud migrations, cloud services, and so on as well. So with that, I'm going to pass it on to Mason. Mason, you want to make a quick intro, and then the rest of the webinar is yours.
Thank you, Sanjeev. Hello, everyone. My name is Maysam. I am an operations research scientist at Cresco International, holding a PhD in industrial engineering from the University of Arizona. I have expertise in developing optimization models and algorithms using very sophisticated optimization solvers. Let's start by discussing production scheduling optimization. At its core, production scheduling is about planning and organizing manufacturing activities to achieve production goals efficiently. Production scheduling is a complex process of balancing competing priorities like deadlines, costs, and resource availability. The key factors we consider in optimization include machine capacity and capabilities, raw material availability, order priorities and due dates, setup times, and equipment changeovers. We utilize advanced approaches like mixed integer programming and heuristic algorithms, such as genetic algorithms, to solve these complex scheduling challenges. The benefits are substantial: increased throughput, reduced lead times, improved on-time delivery performance, and lower production costs. By implementing smart optimization strategies, companies can transform their production scheduling from a reactive to proactive process. Let me illustrate the complexity of production scheduling optimization with a specific example. batch scheduling in pipeline operations. This is an intricate process involving multiple challenges. First, scheduling batches is complicated due to limited tank capacity and significant transportation times that can span several days. Secondly, batches are injected without suppression, which can lead to mixing at batch interfaces. Our optimization techniques aim to minimize batch transitions and reduce contamination. A unique aspect of pipeline scheduling is that transportation times of current batches depend on future batch injections. By applying advanced optimization, we can determine the most efficient times and quantities of oil release to minimize costs and maximize operational efficiency. Now, let's explore an innovative optimization use case in renewable energy, offshore wind farming. In offshore wind farms, underwater cables are critical infrastructure connecting wind turbines to the power station on shore. Optimization here is about designing the most cost-effective cable network. Two key financial considerations drive our optimization. First, the fixed cost of laying a cable is proportional to the distance between stations. Second, cables carrying larger electrical currents require thicker, more expensive cables. Our optimization goal is to compute a plan that minimizes installation costs while ensuring every turbine is connected to the shore and each cable has sufficient capacity to handle generated electrical current. This approach demonstrates how mathematical optimization can solve complex infrastructure design challenges. And energy hub design optimization is a sophisticated approach to creating multi-energy supply systems that integrate heat, cold, electricity, and hydrogen. Our challenge is to design an optimal system that meets our energy demand throughout the year, incorporates complex generation and storage techniques, and finally minimizes total cost and CO2 emissions. By applying advanced optimization techniques, we can create an energy solution that balances economic efficiency with environmental sustainability, determining the most effective generation and storage capacities. On the other hand, our integrated supply and demand planning framework is a powerful solution for comprehensive business intelligence. The key benefits of this framework include integrating data from any source, eliminating manual data preparation, leveraging AI models, and providing end-to-end predictive analytics. The framework enables businesses to seamlessly connect internal and external data sources, transforming raw information into actionable insights across planning, negotiation, execution, and evaluation stages. By unifying data and applying advanced predictive models, companies can make more informed, strategic decisions with greater speed and accuracy. Also, inventory management is a critical challenge for many businesses. Companies frequently struggle with frequent stockouts, overproduction due to poor demand visibility, excessive working capital tied up in inventory, slow-moving stock, and customer service failures. Our inventory optimization approach addresses these challenges by determining optimal inventory levels that meet customer demand at the lowest possible cost. The benefits are substantial. For example, reduced distribution and procurement expenses, improved service levels with less inventory, optimized safety stocks, time phase replenishment plans, and finally, reduced need for expedited production and transportation. It should be noted that our solution uses advanced machine learning engines, demand forecasting models, and sophisticated algorithms to generate optimal inventory policies, reorder points, and safety stock levels. Our inventory optimization solution offers a comprehensive set of features designed to transform inventory management. So it includes inventory segmentation that strategically categorizes and manage inventory, inventory planning that creates intelligent data-driven inventory strategies, visual analysis and reporting that gains insights through intuitive dashboards, workflow automation that streamlines inventory-related processes, stock adjustment and position tracking, purchase and sales order management, self-service exploratory analysis, and finally, scalable and adaptable to organizational changes. This solution provides businesses with the flexibility, visibility, and intelligence needed to optimize their inventory management efficiently. And workforce scheduling optimization is another critical area where advanced analytics can drive significant improvements. Take healthcare as an example, specifically nurse scheduling. The optimization engine considers multiple inputs like employee and shift information, service periods, labor costs, predicted demand, minimum service levels, and individual employee skill sets. By harnessing powerful optimization engines, we can create unified data source for scheduling. We can explore millions of scheduling alternatives, and also we can conduct what-if scenarios to predict schedule impacts. Nurse scheduling optimization addresses critical challenges in healthcare workforce management. Key factors we optimize include nurse availability, equipment and staff resources, patient priority and urgency, and procedure duration and estimates. We use advanced techniques like mixed integer programming and constraint programming to create optimal schedules that improve resource utilization, reduce patient wait times, increase patient satisfaction, and deliver significant cost savings. Currently, nurse schedulers spend up to 650 hours annually on non-nursing administrative activities. Our optimization solutions have shown that 46% of schedulers can save up to 12.5 hours per week. And optimization aims to revolutionize resource management through advanced analytics. Our key capabilities include unifying data across the organization to create a single source of truth. We can harness powerful optimization engines to evaluate millions of potential alternatives and conduct comprehensive what-if scenarios to preview decision impacts. The process follows a strategic workflow. So we should receive nurse availability and skill sets. Then we can perform what-if analysis. After that, we can allocate resources to shifts. Then we should update allocations by skill set and run optimization models, which includes defining and updating mathematical constraints. This approach enables organizations to optimize plans, schedules, and actions while driving business processes through high-level KPIs and exploring multiple scenario alternatives. Creating an optimal schedule involves a systematic data-driven approach. At the first step, we should receive nurse availability and skill sets. And this process begins by collecting comprehensive information about each nurse capabilities and availability. Then the user should conduct what-if analysis. In this phase, the user can simulate various scheduling scenarios to understand potential outcomes and challenges. After that, the user should intelligently assign nurses based on their skills, availability, and organizational needs. And the user can get help from the optimization engine. The next step is updating nurse allocation. And after that, we have run optimization deploy. And in that phase, advanced analytics can be used to generate the most efficient schedule. And finally, we have defining and updating mathematical constraints. So we should continuously improve the scheduling model by adjusting parameters and constraints. The result is a sophisticated dynamic scheduling solution that maximizes efficiency and meets organizational goals. And the results are impressive. Annual wage savings of $350,000 for small emergency departments and up to $950,000 for larger departments. Another important use case is crew scheduling optimization. Crew scheduling optimization addresses the complex challenges airlines face in managing flight personnel. The key challenges include adhering to legal regulations on maximum hours and rest periods, meeting contractual obligations and crew preferences, and ensuring cost efficiency by minimizing overtime and travel expenses. And our solution approach utilizes integer linear programming to model crew pairing and rostering, as well as heuristic and meta-heuristic algorithms for rapid, near-optimal solutions. And the impact of the solution is significant. The impact includes reduced cost by minimizing non-productive time, ensured regulatory compliance, and improved operational reliability. Another important use case of optimization in airline industry is seat and gate assignment. Seat and gate assignment optimization focuses on two critical areas of airline operations. First, let's take a look at seat assignment. It balances passenger satisfaction by keeping families together. It maximizes revenue through premium seat upgrades. Also, it uses dynamic programming to allocate seats and applies revenue management models to prioritize higher paying customers. The next important optimization solution is gate assignment. Gate assignment minimizes passenger transfer time. It prevents airport congestion and optimizes gate allocation for efficient aircraft and passenger movement. The results are enhanced passenger experience, improved operational efficiency, and significant reduction in delays and resource conflicts. By applying these sophisticated optimization techniques, airlines can transform a complex logistical challenge into a strategic advantage. Also, I want to talk a little bit about pricing optimization. Pricing optimization uses advanced mathematical models to recommend strategic price actions that maximize business metrics while respecting critical constraints. Key objectives include determining demand at each price point, setting market prices to maintain or grow margins, identifying the most profitable price to move desired product volumes, and it's worth mentioning that our optimization models help businesses maximize profits, meet volume targets, minimize supply chain costs, and enable pricing analysts to focus on exception handling. By systematically optimizing prices across all products and terminals, companies can transform pricing from a reactive to a proactive strategic function. Our integrated supply and demand planning framework represents a breakthrough in data-driven decision-making. This approach offers 4 key benefits. First, it can integrate data from any source and any value, eliminating manual data preparation and cleansing. In fact, This approach can save up to 90% of traditional data work. Second, it leverages leading AI models to transform raw data into actionable insights. The framework covers the entire business process from planning to negotiation to execution and evaluation. By combining internal and external data sources, we create a comprehensive predictive analytics solution that provides end-to-end visibility across the organization. This means better insights, improved authorization and security, and more holistic view of business operations. Our integrated supply and demand framework provides a comprehensive approach to pricing and trade promotions by combining multiple data sources and advanced analytics. Key components include internal data sources like product master data, customer information, and pricing data. External data sources such as consumer data, brand ratings, and weather information. The solution offers end-to-end supply and demand capabilities, answering critical business questions such as what does the company sell normally? What are the best promotions? What are the total financial figures? By integrating baseline and promotional data, we create a holistic view that enables more accurate demand sensing, financial forecasting, and strategic decision making. Our approach ensures that even with limited external data, AI-driven insights remain possible and valuable. Our final focus is on pricing and trade promotion optimization in retail, a critical area with significant financial implications. Trade promotion is the critical relationship between manufacturers and retailers, aimed at increasing sales, enhancing brand awareness, clearing inventory, and building customer loyalty. By applying advanced mathematical models, we can transform pricing and promotional strategies from guesswork to data-driven precision, ultimately improving profitability and market competitiveness. Did you know that only 33% of trade promotion in the US are profitable? Companies spend 15 to 25% of their revenue on trade promotions, making optimization crucial. Our approach follows a build, measure, learn, and repeat methodology, focusing on improving trade promotion effectiveness, continuously optimizing strategies, and maximizing return on investment. We use sophisticated mathematical models that consider maximizing total profit, minimizing total costs, business constraints, product baseline revenue, promotional costs, and demand forecasting. In pricing and trade promotion optimization, business constraints play a crucial role in developing effective strategies. Key constraints include separating promotional periods to preserve brand image, preventing customers from becoming deal seekers, selecting prices from a discrete price range, and limiting the number of promotions. These constraints ensure that the brand maintains its perceived value, pricing strategies remain strategic, customer behavior is guided thoughtfully, and finally, promotional activities remain meaningful and impactful. By carefully defining and implementing these constraints, companies can create more sustainable and effective pricing and trade promotion strategies that balance short-term gains with long-term brand positioning. Now we are going to talk a little bit about some implementation and closing thoughts. Ask yourself these 4 questions to find out if your company uses mathematical optimization. First, do you have a business problem involving a complex, interconnected set of decisions? Optimization thrives where decision interactions are intricate and difficult to track manually. Second, can you quantify and compare the outcomes of your business decisions. Mathematical optimization requires the ability to mathematically define what makes one solution better than the other. Third, would more efficient resource use unlock new opportunities for your company? If you are operating with constrained resources, optimization can help you maximize efficiency and drive business growth. Finally, does your company operate in constantly changing business environments? Mathematical optimization uses historical and real-time data to deliver instant solutions, enabling rapid response to changing conditions. When implementing mathematical optimization, you have three primary pathways: off-the-shelf software product, consulting partner, and in-house team. First, the off-the-shelf software product approach. This is ideal for companies facing standard business problems with limited budget and shorter project timelines. These products are typically less expensive, easier to integrate, and come with embedded optimization solvers. Second, the consulting partner approach. These experts help identify key cost and growth levers, creating customized, scalable optimization applications. While more time-consuming and costly, this method can deliver significant long-term ROI. Our optimization consulting focuses on three key areas. First, problem formulation. We can help articulate business problems quantitatively, identify principal metrics, and formulate mathematical models. Second, decision framing. We assist in choosing the right solution approach, whether strategic or tactical. This involves comparing optimal solutions, understanding robust alternatives, and facilitating trade-offs between multiple objectives. Our team brings expertise in translating complex business challenges into precise mathematical optimization and strategies. We don't just provide a solution, we provide a pathway to more intelligent, data-driven decision-making. Third, the in-house team approach. By assembling experts in analytics, operations research, and data science, companies can build deep, unique understanding of their business problems and continuously expand optimization capabilities. Although the costs associated with hiring in-house resources can be substantial, the potential benefits of having these experts within your organization is immeasurable. And there is no universally right approach. Many companies adopt a hybrid model, often starting with an off-the-shelf solution and evolving towards a custom in-house capability. For example, we can say one strategy should be working with a consulting partner to implement an off-the-shelf solution, or one strategy should be engaging external experts to collaborate with an in-house team. Thank you for joining us today. We've explored how mathematical optimization can transform operations across industries, from manufacturing and healthcare to energy and retail. The key takeaway is that optimization is not just a technical solution, but a strategic approach to make a smarter, more efficient business decisions. If you're interested in exploring how optimization can benefit your organization, please reach out to us at info@crescointernational.com or visit www.crescointl.com.
Mason, thank you, Mason. I have a few questions. Can I just ask you? So this is from our chat. So one is, what is the primary goal of optimization? Is it to cost minimization or profit maximization?
So the beauty of mathematical optimization is that you can consider and add any any objective value or goal to your mathematical model. You don't have to be limited to maximizing profit or minimizing cost. You can add a variety of goals. whatever you want. For example, minimizing the waiting time of patients in a clinic or hospital, or maximizing the fairness of work schedules in a work environment for all of your agents or workforces, and many other objective functions. And it's not just about the objective function or goal of the problem. You can add as many as business rules or constraints that you have in your specific business. So the strong point and the strengths of mathematical optimization is the flexibility, and the flexibility means defining your own goals and constraints within the model.
Okay, awesome. There's another question. How does optimization differ from other analytical approaches such as machine learning or descriptive analytics?
Okay, great. Good question. So machine learning is a little different in terms of the value it brings to your organization. So what machine learning does is predicting the future. Although it predicts the future, it doesn't give you the best course of action. It doesn't give you what are the best decisions. So you should use this prediction to make actions, to make decisions. In order to make the best decisions, you need to use optimization. So optimization gets these predictions from machine learning, like, for example, your demand in the next 6 months, and then make the best decisions based on that predictions. For example, it generates optimal inventory plans or optimal production schedules that lead to maximum profit or minimum cost, or, for example, maximum customer satisfaction. Another important difference is that the machine learning should be retrained periodically and regularly based on the fresh data. But mathematical optimization works differently. It is very, very flexible, and it can adapt to your business environment easily.
Okay, and one final question. What resources or skills would you recommend for someone looking to learn decision optimization?
That's a great question. Specifically for data scientists and managers who don't have this optimization skills, I think the good point is learning how to develop mathematical models and how to use optimization solvers to solve their optimization problems using the developed models. And at Cresco International, we provide training workshops for different levels of expertise, from entry level to advanced scientists or managers. So I strongly recommend that you join our workshops to learn how to use optimization engines and how to develop optimization models in order to take advantage of the data you have available in your organization, and combine it with machine learning and other AI tools that you already have in your organization.
Fantastic. Well, Mason, thank you very much. Thank you to everyone who attended today. Appreciate your time. I know we got done pretty quick, and now we can pass it on to the team that will manage the pizza making session, and we will sign off. Thank you, guys.
Thank you. Have a good day.